Hello friends, in this module we will learn about multi-dimensional association rules. Multi-dimensional association rules are used to find the frequent item sets. A Boolean matrix based method is used here and the items that form a rule come from different dimensions. Basically, it is an algorithm from relational databases for mining multi-dimensional association rules. Let us see the characteristics of attributes in this association. Attributes can be categorical or quantitative. Quantitative attributes are numeric and incorporates hierarchy. Numeric attributes must be discretized. One more property is that multi-dimensional association rule consists of more than one dimension. For example, a person X who buys a laptop computer also buys inkjet printer. In this way, we can have multiple dimensions in the rules. There are three approaches in mining multi-dimensional association rules. In the first approach, we are using static quantitative attribute discretization. Discretization is static and pre-mining occurs. Discrete characteristics used here are classified as categorical. In this approach, we can use the a priori algorithm to discover all k frequent predicate sets, that is k or k plus 1 table scans are required to do so, and each frequent set of predicates must be regular. For example, if in a data cube the 3D cuboid which represents age, income and vice is frequent, implies that the item sets combined as age and income and vice are also frequent. Data cubes are well suited for mining since they make mining faster. The cells of an n-dimensional data cuboid correspond to the predicate cells. Let us see the second approach. Second approach is where we use vibrant quantitative attribute discretization. It is also known as quantitative association rules mining. Numeric characteristics are discrete dynamically. Let us see an example. A person X who is in the age of 20 to 25 and has an income of 30,000 to 41,000 buys a laptop. You can represent this in a tabular form where you can list out the age categorized from 20 to 25 and the salary in different ranges. In this way, it is discrete. Third approach uses a distance based discretization with clustering. This is dynamic discretization process that considers the distance between data points. It involves a two-step mining process. First, you need to locate the interval of characteristics concerned that perform clustering. Next, you have to obtain rules of association by looking for cluster organizations that happen together. And the resultant rules may satisfy two properties. One observation is that clusters in the rule antecedent are strongly associated with clusters of rules in the consequent. Another observation is clusters in the antecedent occur together and clusters in the consequent occur together. Association rules can be categorized in a variety of ways based on the following criteria. The first criteria will be Boolean and quantitative association rule. The rules which concern only the presence or absence of items are known as the Boolean association rule, either a yes or no. If a rule defines association between quantitative items or attributes, then it is a rule of quantitative association. In these rules, quantitative values for items or attributes are divided into various ranges. The next type is single dimensional and multi-dimensional association rules. If in an association rule, the items or attributes do not take into account any dimension and consider all items in one dimension, then it is called as a single dimensional association rule. If a rule suggests two or more dimensions, then the rule of association is multi-dimensional. Now, let us look into the third type, which is single level and multi-level association rule. When finding association rule, if items are not considering any abstract level, then it is called single level association rule, and when we consider items at various levels of abstraction, then we call such types of rules as multi-level association rules. There are many examples for this. The fourth type is based on the nature of the association involved in the rule. Association mining can be expanded to correlation assessment, where it is possible to identify the lack or presence of correlated items. but we are only concerned with multidimensional association rules because it may be helpful in some cases to discover rules between items from distinct levels of the concept hierarchy. For many applications, it is hard to find powerful connections between information items at small or primitive levels of abstraction owing to the sparsity of information in the multidimensional space. Then what might be common sense to one consumer, however, may seem novel to another. So, it depends and varies according to the customers. Data mining devices should therefore be able to mine the rules of association at various levels of abstraction and also readily across distinct spaces of abstraction. Now, let us see what is multidimensional association rule. Most algorithms and methods concern only the rules of association within the single attribute and Boolean data. All these rules are about the same attribute and the value can only be either yes or no, 1 or 0. Multidimensional association rules can be generated by mining rules in various dimensions also. For example, a person X in the range of 19 to 24 and who buys a laptop also buys a black and white printer. The aim of mining multidimensional association rule is to find the correlation between distinct predictions and attributes. A dimension in the specified instance may be an attribute or a predicate such as era, occupation and purchases. Multidimensional association rule mining concerns type of information such as Boolean data, categorical data and numerical data. Here the method of mining is easy, but three fundamental methods are used to generate various dimensions. Let us see the first technique. In this technique, a quantitative attribute are divided into distinct ranges according to the specified hierarchies and attributes are substituted by separate ranges previously to the mining process. It is also possible to generalize categorical characteristics to a greater concept level if needed by the customer. The appropriate information can be stored in the table after this process. The appropriate information can also be stored in the data cube, which is more appropriate for multidimensional association rules. This is because by definition the data cube itself is multidimensional. The a priori can be readily adjusted by searching all appropriate characteristics instead of just one attribute to get the regular k predicates. Let us see the second strategy now. The second technique utilizes the technique of dynamic discretization. During the mining process, quantitative characteristics are dynamically discrete in this technique so that some minimum support is satisfied. Agrawal has implemented quantitative association rules for mining. Another strategy utilizes discretization based on range. For each attribute, distance is used in this technique to extract the quantitative characteristics instead of the concept hierarchy process. Here the values close to each other are grouped in the same interval. There are two steps. First of all, clustering methods is used to produce clusters or intervals, and then distance based association rules are produced by testing for frequently occurring groups or clusters. Hence, during the phase of rule formation, the related parameters were used as metrics. Density and frequency are included in those parameters, and there are many other parameters also. Regulations which meet certain minimum density and frequency thresholds are taken as interesting guidelines in this situation while you mine a multidimensional association rule. Now, let us look into how to mine a multidimensional association rule. There are three multidimensional association mining methods. Our primary focus for the multidimensional association rule mining is the static discretization method. Discretization, as we have seen earlier, is a process that transforms quantitative data into qualitative data. Let us see an example. In descriptive terms such as young and old, quantitative data represented by the age attribute in numerical values are represented. It will divide the quantitative attribute value range into a finite number of intervals as we have seen in the tabular column before. The mapping function associates all quantitative values to a single qualitative value in a single interval. A cut point is a quantitative attribute value where an interval border is located by a mapping feature. Various taxonomies exist in the literature to categorize discretization techniques that are complementary, each relating to a different dimension along which discretization techniques can differ. One such technique which you can see here is to use the hierarchical discretization to pick cut points using an incremental process. This generates an implicit hierarchy about the value ranges. In addition, hierarchical discretization can be defined as either divide or merge. Split discretization begins with a single interval covering the entire value variety, then constantly dividing it into a distinct interval, then repeatedly merging neighboring interval until a stop criterion is met. This is how the multi-level association mining works. Now, let us see an example. In this example of multidimensional association rule mining, the concept hierarchy is represented. In this picture, you can see a cross-level relationship between milk, sunset and bread to wheat. In this rule, milk is upper level and sunset wheat bread is at lower levels of hierarchy, thereby generating a cross-level association. Let us see an algorithm in this technique. MLT2 is basic multiple association rule mining algorithm that generates item set at same concept level and each level has different support. This algorithm can be used to find multiple dimensional association rules by slightly modifying it and considering same support for all the levels. Let us see the steps in this. This algorithm basically takes the input of a hierarchy information encoded and task relevant set of transaction database in the format of transaction ID and item set, in which each item in the item set contains encoded concept hierarchy information. And another input is the minimum support threshold, the minimum support of I for each concept level 1 or I. The transaction table represents the data where each instance in the data set represents one transaction of the form record ID and item set. Item set is the list of items for that record ID. Now, what is the output of this algorithm? The output is the multiple level large item sets generated. Let us see the method that is applied in this algorithm. The method is a top down progressively deepening process which collects large item sets at different concept levels as given below. Starting at level 1, derive for each level 1 the large k item set I comma k for each k and the large item set L of I for all k's. Thereby, we move from one level to another arriving at the largest item set. And our goal is to generate frequent item sets from this algorithm for mining strong cross-level association rules. Rules involving more than one dimension or predicates are very useful. Let us see an example for that. A person X buying a laptop computer also buys a HP inkjet printer. Here what we see is a single dimensional association. Let us now see a multi-dimensional interdimensional rule. That is, a person X with the age of 20 to 25 and who is a student buys a HP inkjet printer. Here you can see the interaction between different dimensions such as age, buying characteristics and what are all the items that is bought by the customer. Now, let us see the characteristics of attributes. The attributes can be categorical or quantitative. Quantitative attributes are numeric and incorporates hierarchy like age, income. Numeric attributes must be discretized. Three different approaches are followed in mining multidimensional association rule. First one is using static discretization of quantitative attributes. Another one is using dynamic discretization of quantitative attributes, and the next one is using distance based discretization with clustering. Now, let us see the summary. This module demonstrates that mining multidimensional knowledge is both practical and desirable. We have successfully discovered multidimensional association rules using MLT2 algorithm. The association rules discovered provides more specific information for the users at cross levels of abstraction. And the algorithm also has efficiently discovered multidimensional association rules from two data sets. We have noticed that the execution time of the algorithm depends on the size and complexity of concept hierarchy discovered, and hence it is variable for different data sets. Moreover, the algorithm discovers association rules for successive levels, making use of rules already discovered for upper levels of concept hierarchy. The number of association rules discovered depends on value of parameters at each level like support, confidence and lift. Hope you have got an idea of what is a multidimensional association rule, how to mine that rule and what are all the dimensions involved in that rule, and the support confidence measures which we have to take into account while we mine such rules. Thank you.